Okay, let's start. So I write colab Google, search for it. I click on Google Colab and I want a new notebook. So I open a new notebook. Voila, we are there. So that's our Jupyter Python notebook here. That's the first line. To get familiar, we have some options here. Search, you can search for comments here, for example, which are previously written, but some other people. You have a kind of temporary folder on Google here. There are some samples already uploaded on the left. So we went through these options on the left side. Like any other languages or softwares, we have several options on the top, like file. You can import, save, or open new notebooks, delete stuff, paste, view, insert, and so on. And in the second row on the top, we have two options, code and text. Text means you can add some text in your Jupyter Notebook just in order to document what you are doing. So I'm gonna do that now. It's a kind of so-called Markdown language, which is for documenting your notebook. So you just can collect Markdown cut. So I try to write some title for our code. Let's say Jupyter Notebook to plot the land surface temperature anomalies by country name. So you can see on the right side how it would look like if you run the code. So I'm finished. So to run each of the lines in the Jupyter Notebook, you can just easily click somewhere else. You can see the results here, and you double click on the line that you have written. You can see the code or the text code itself. So it's kind of a Markdown language. You can, if I don't put this hashtag symbol, it's gonna be a simple text in my Jupyter Notebook. But in Markdown language, one hashtag means a big title, and two means, for example, second title. So you can play around with it if you like. And for adding code, Python code chunks in your Jupyter Notebook, you can easily just click on the code. So, and to change the name of your Jupyter Notebook, you can easily click on the untitled. You can see here up, untitled one. You just click on it and you write, for example, temperature plots and hit enter. Now it's saving it as temperature underline plots IPython notebook. So let's get started. The kind of data we want to use is coming from Berkeley temperature anomaly dataset, berkleyearth That's a very nice organization who has collected the temperature dataset or other dataset like COVID-19 or air pollution dataset, but we are interested in global warming dataset. So you can search for the dataset that you want to plot here, data overview, and regional, this one, so by countries. So what we want to plot now is the time series data land only over land. From the data is starting from 7050 to recent, if we are lucky, but I don't know, for countries in Central Asia maybe the time series is shorter. And this one, so regional average of temperature by countries. So you can see for each country you have the data. Let's say for Afghanistan, if you click, you see where the Afghanistan is, and you can see the time series. But what we want to do is to plot this time series by ourselves. Actually, if you can here also download the image or the data table. So you have here some description about the data. For example, what is the anomalies are estimated against which period. Here you can see estimated from January 1951 to December 1980 absolute temperature. So that's a reference period. And then you have many columns, like years and months. So that's the monthly anomaly. And monthly anomalies and its uncertainty, because the data set has provides you also the uncertainty in the anomalies. That's very nice to have. And the annual values, there are kind of a smooth time series of monthly values. 5-year anomaly, much smoother. 10-year anomaly and 20-year anomaly. So we want to read this data set in our Python code. So if you look at the URL or the address, you can see everything. If I change here the name of the country, I would land in the other data set. For example, let's say Germany here. Then I would have Germany here. Here you can see the name of the Germany. So I would try to read this address by changing just the name of the countries. Yeah. So let's go back to our code. So we gave the code a title. Now I want to first of all to tell the code which countries I want to plot. In Python you can write comments. Comments means the lines which are not gonna be executed by the code, by putting again this hashtag in front of the code. You can see that the line would be green colored, which means it's not gonna be executed, but it's gonna give us hints what we were doing, or somebody else who wants to read our code. So I write here you can insert the target country names. Yeah. Names. So if I execute this code, nothing will gonna happen. Now I write countries equal to a kind of list of the countries that I want to plot. You know that strings should be between the quotations. So Kazakhstan, and the other countries. Now I have selected my countries. Now for reading and plotting the dataset, which is shown in this text, data on web, which we have seen that by changing just the name here in this string, we can reach other countries. We need 3 different Python libraries that we have to load. So I just load them here. Import needed libraries. The first one is the matplotlib. We need that for plotting. The good thing about this colab Python notebook is that it can guess what you want to write here. That's very nice. And from matplotlib, I just need the pyplot part. You see? I write here for plotting some comments. It's always good to write comments in your code. I need also to make the date for my time series. So I also import date time. From date time, I import date and time delta to build my data access. And finally, I import pandas, which is a nice library for working with data frames. Data frames are like like Excel tables, which you have different columns and different names and different rows. So these pandas makes our life easier when you're working with the tables, which you could always see in this data. So it's kind of table. From here on, you see the table. There are some descriptions which, when we want to load this data, we have to kind of skip these descriptions, which have this present sign on the left side, and go all we need is this data here, the year and the other columns. Okay, let's go and read this data set. So let me just copy this R here. I will copy this R here. That's a kind of text. So I write here my country. We start with the first country. Let's say countries, the first one, which is the Kazakhstan. And here I remove Germany and add my country. I put this variable's name Earl. So we can also tell which variable we want to plot, because there were 3 different variables in the dataset. If you remember, if I go back, yeah, there are different variables. So we have mean temperature, we have maximum temperature also. So if you, for example, click on the maximum temperature, the R will change to T min. So we have Tay mean, Tay max, and Tay average. So I can also put another variable. My var would be, for example, let's first plot the T average. So I can change this variable in the Earl to my var. So I can also print my Earl now to be sure that everything is working. Now I have this one. I have regional, T average, Kazakhstan, and TAVG. So, but there is a problem which I will mention. If I click on that, I will land nowhere. The problem is in the error, name of the country is written always in the lowercase, not uppercase, like small k. Now I land in Kazakhstan T average time series, which just starts from 1832. So to solve this problem, we could put Python's function called lower. So now we should have Kazakhstan in lowercase. Now if I click on it, I land on Kazakhstan time series. So that's nice. Okay, so we have the error now. So, but how could we read that data? I already loaded the pandas. Pandas has this ability to read comma separated vectors or data from the error. With I name my data frame df with this function read CSV here, this one, read CSV. We need the URL and some options. You can see there are some options here shown, delimiter, how they are separated, or header, how many lines we have to skip rows, and so on. I previously played with these options, and I actually counted how many lines we have to skip, what the names of the columns should be, and etc. So I landed with these options here. So the separator is kind of the space, but the length of the space is between the data. If you look at the data, is changing more or less. Here you have, I don't know, 3, here you have 4, here you have some tab here, so everything is changing in the data set. And at the end I came up with this setting here, these options. So the separator, the spaces, the comment is the present. You can see here, these are the comments. And use columns, which columns we're gonna get from 0 to 12. And name of the columns, I took them from this line, the anomaly and the uncertainties. So we have 12 different columns. So if I run the join now, we should have our data frame here. So df, I take the head. Now we can see our data very nicely from Kazakhstan. So we have the year, we have the month, a monthly anomaly, monthly uncertainty, yearly anomaly, yearly uncertainty, 5-year anomaly, and 5 years uncertainty, and so on. So we have our data now. But the next step is for me to write, because I want to play with different countries, maybe more than 1 or 6 or 7. So I don't want to rewrite these lines again and again. So the best practice would be to use a self-defined function, because we just have two different variables. So the country name and the variable that we want to plot, average temperature or minimum and maximum daily temperature. So we're gonna have a function with two variables. So I define a function here. I call it extract country name is one variable, and the variable. And now I put everything here. So the error would be, again, very easily put it here. Oops. So that's one. And again, here you take this. And then return df. And I take everything out now. Let's check that. So I run the thing. Now I write extract country. So the country would be, let's write Kazakhstan, and the variable would be TAUG and df head. Let's see if it works. Yes, it's working. So you see, now we are able to read any country's data set, temperature anomaly data set from the web without downloading the data. Now let's plot some plots here. Okay, now we can plot, for example, Kazakhstan's data. PLT plot, let's say df point, or we do it like that. Let's plot 5-year anomaly. Oh, we have done some plots, yeah, here. Oh. Now you have the 5-year anomalies of the Kazakhstan. But the problem is we could not plot the x-axis or the time axis. Yeah. For plotting the time axis, we can use this date time library to create a nice x-axis. So what we can do is we can write like create the start date. Let me first remove that. So that would be my start date. S date. You see the start date, I put it 1st of January 1832. In the same manner, we plot the end date. oh, we get a problem because in Python, yeah, we need to put yeah, because of the data frame, we should use this ilog function. Oh, the year. The argument gets the float, so we have to change it to integer again. Yeah, there's always some. Yeah. Okay, now we have end date and start date. Very nice. Now we build the whole time series. By this command. I call it dates with dates would be a start date, range, date range between the start date, end date, plus time delta every 30 days. I want to move every month. Frequently monthly, create data. Okay, so now we have our dates. So let's plot again with dates and my data frame. I wanted to plot the monthly or 5-year anomalies. Now we have a very nice X time axis. For making the plot nicer and to plot everything in a loop, you can add some options to your plot, like yeah, to tell the figure, okay, which size should have the figure, because the upper figure is more or less, you can stretch it to right by telling that I want to have yeah, this ratio, like 12 for the x-axis and 5 for the y-axis. You can change the font of the plot. Here I have chosen serif and with lightweight and size of 15. And with this command, you can change the plot configuration. This command I can delete. Now I tell the code I want to have variable name of average temperature for all the 6 countries. First print the country for me and then extract the data frame of the country from the web. Produce the start date and the end date, because each of the countries have different time series lengths, and then produce the time axis for me, and then plot the data. Here I have chosen just from to plot. I just wanted to plot from year 1950 onwards. That's why I start from 852 point to the end of the time series. yeah, and then I want to also plot the uncertainties. So you have the anomaly, the mean. Here I read the mean and the uncertainty, and I fill between mean minus uncertainty to mean plus uncertainty, because if your uncertainty is 1 degree, it could go it could be 1 degree less than the mean or 1 degree more than the mean. And I make it transparent with this alpha comment, and the face color of the shading I put black. So if you make the black transparent, you're gonna have a gray shading. And I want to have legend with 3 columns, font size and no frame. I name the X label as year and one Y label as temperature anomaly. 5-year moving average, because I'm using the 5-year anomaly. And finally, you can also save your figure with the name TA average PNG, and with a tight box and DPI, the resolution 300 pixel DPI. Let's see how it works. Now I'm reading different countries plus Afghanistan. You have now a very nice plot of the TA average temperature anomaly, 5-year moving average for different countries in Central Asia plus the Afghanistan. You can see that since 1950s to today, we have kind of rising temperature of more than 1.5 degree, even 2 degrees in Central Asia. You can do the same thing for T mean or T max, and I can also use this variable for naming my plot, which is gonna be saved. Now everything is automatic. You just have to change the country's name and the variable name here, and then you're gonna have this this plot here, which has been saved, and you can download it on your PC. So let's say TA average. I save it. Yes, here you can see the plot very nicely.